Video is about sample rates in audio files people looked at on the internet over the last couple of years trying to find lost media. Now this is about a lost media mystery that's been solved. Nobody should watch this video in reference to it. This is a generalized video about it. I'll bring up the information, but let's just say what's on the screen. If you find a 15 kHz signal in a MP3 file or any other audio file recording, and it's sampled at 32 kHz, that means you're dealing with around a 2-to-1 sample rate, or double oversampling. Now, the minimum sample rate, if you're trying to determine the shape of the signal, whether it's a sine wave, a square wave, a sawtooth going up or down, the minimum sample rate should have been around 47 kHz, or usually it's listed as 48 kHz or something like that, as in a triple oversampling. If you're trying to determine if the said signal was a sawtooth, sine wave, or other. This includes up and down ramped sawtooths. Now, this is mostly important for the following statement. A, do TV sets that use flyback coils, these are the high voltage, big heavy monitors that use a big glass container for the display device. It's called a cathode ray tube, CRT. Do you believe that you can record that with a microphone or with the microphone slung over the top of or being near a TV set, which means you're putting it right next to the speaker in the TV set, recording something off the air, or recording something off of a video you rented from one of those video rental stores? That's actually a reference to the actual file we were talking about. But anyway, if you do that, do you really believe you wouldn't pick up the noise from the cathode ray tube as it getting into the microphone cable as a electromagnetic field when it's using literal electromagnetic fields to bend the electron gun's beam? Do you believe that it might also pick it up as just an audio signal? I saw no one do this experiment with a TV set that would have been available around the year 2000. And yes, TV sets still existed, and not every system had phased out 15 kHz flyback frequency. Now, it doesn't help us, but it definitely helps the television industry that broadcast and non-broadcast, yes, I said it, video signals sometimes contain this flyback frequency-like signal being used to indicate stereo audio. I know that last part's going to trigger a bunch of people, but there are other systems that were set up that included it in band in the audio. Yeah, that's kind of how it worked at one time. And not all systems would filter it out, because a cheap system could omit it because most people didn't hear the amplified 15 kHz because it would be very necessarily almost identical or literally a copy of the flyback frequency. There were some differences depending on if you had a signal that was based on the color burst versus the black and white 15 kHz, and also what era. But that doesn't make a difference because all of the electronics are made sloppy enough that they can tolerate that. And yes, you could watch a VHS tape and get this kind of signal. And also it should be pointed out that these are analog oscillators. They're not precisely timed. They would adjust by using phase lock loops for the video screen because that's how it would line up the screen anyway. You understand that, right? Now, of course, everything I've said is subject to opinions being taken as fact on the internet, and people are going to ignore me. I know that already. I know someone is immediately typing, for technical reasons, I have to argue with you. But you also know for technical reasons, I'm right, if you know about the subject matter. Not everywhere on the planet used the same proper standards. So the sample rate should have been a higher frequency. Now, in that case, it's an audio recording made as an MP3, and it was done through a microphone on someone's computer. So someone used a computer to record this, not on analog equipment, but to immediately encode it. Now, the MP3 that everybody got, and it's the only one we got, is a 32 kHz sample rate, let's say. Yes, I'm going to say that because I'm rounding numbers off here, or I'm not. Your job, if you want to argue with me, is to find the original file, for everyone knows that, or whatever file it is, because that's not the only one. and tell me what the sample rate is. I could be talking about 5 or 6 other freaking audio recordings, and the sample rate would be around 30 kHz. It's still very close to double oversample only. The sample rate of 4800 allows you to reliably detect and measure the intensity of a 15 kHz signal, but not its shape. But at minimum, that would help, because if it's a continuous signal, there's no reason to assume it is, but let's say it's continuous, you could oversample based on each of the recurring samples and try to clean it up, except for one thing. Constant bit rate isn't always used. Variable bit rate became very popular, and the recording we're talking about, if we're talking about everyone knows that ulterior motives, was during a time when people would pick VBR or CBR or other. There's more than one bit rate sample, but let's look at the effect. This is a waveform here of the signal. Now the signal is either the input or the output. Let's assume under ideal conditions we've perfectly reproduced it, right? Okay? Now what we have here is these are the only samples. These orange ones. It has to interpolate where the peaks are. Now, if the peaks are there, if it's using a compression system that's fairly sophisticated, it'll indicate when the samples were taken and when a peak was detected. Peak detection isn't necessarily going to be used back then, but it was available. All right? All right. Okay. Even though this was probably someone's, consumer grade, probably a compact or something like that, who knows what, an Amiga, who knows, with a electric condenser microphone that's obviously able to pick up the signal, or the cable was really close to a cathode ray tube TV set, and the guy was using a VCR to play it back, and the TV set was being picked up as a sawtooth wave. A bunch of people have even claimed that it is a sawtooth wave, but that means it has to be a stereo signal off of a broadcast signal. Now, obviously, as we know now, unless some local TV station was broadcasting a porn, no, it wasn't. I'm right. So anyway, this is the ideal situation, right? You get these samples obviously at the wrong level, but you have peak detection. Or you don't. Maybe it just guesses at it. Okay, let's move it over like that. Now our original sample and the interpolated signal have to be the same level. How does it do that? Well, it doesn't show a peak detection. I'm using this from a website that I'm not indicating exactly what they said on the page. These are heavily mucked up versions, but I'm trying to show you why this ambiguity is a problem. Now let's look at the next one. Now we have the real world example. Your sample rate isn't exactly 2-to-1 even, or 3-to-1, or whatever. It's not a multiple of it. So you're sampling over this, and this, with some variation in the volume level. We're talking a tiny amount here. We have our original samples being at different voltage levels, but this thing's doing either constant or variable bit rate, and the thing is figuring out, hey, we should interpolate other signals. So here's our sample here at one peak and another. Here's the other one at this peak. This is actually another peak. These are near peak, and these are off peak. And it figures out, because it's not a multiple, it doesn't assume it's going to be exactly a multiple of it, that if we get samples happening with this kind of crawl over, this beat frequency, if you're not aware of it, that looks like a wave shape. Here are samples going up and then back down towards center. The same way, the enveloping effect here, acting like a beat frequency, tells it, yeah, we need to interpolate between and do a better job. Okay, but here's a sample here and here. That looks like a rising edge for a sawtooth wave, maybe, or a triangle wave. These samples show a triangle wave, or maybe you could decide it's a sawtooth. You have to assume it's a sine wave because you're assuming it's going through the air. Most audio signals are going to average out to being sine wave based because they use fast Fourier transforms, presuming sine waves. To review, unless you have a sample rate at least 48 kHz, if you're trying to evaluate something at 15 kHz that is inside of the sampled signal, it has to either be a variable bit rate, so it accommodates for high, low, and medium frequencies, having different sample rates, and then uses whatever the highest one is that would be needed. which means throughout the recording, the VBR would have switched from, let's say, 32 averaged kHz up to 48 kHz because it was detecting this very prominent 15 kHz signal. If it isn't doing that, if it doesn't have these smarts to do it, you cannot evaluate whether it's a flyback frequency off of the back of a TV set through the air, being turned into a sine wave, but still kind of being interpreted because you have no data, and you can't interpret it whether or not the microphone was simply laying or setting next to a literal TV set, interfering with the shielded cabling, injecting a 15 kHz signal that is amazingly stable, and that's probably what it is. And still, you wouldn't be able to see whether it's a sawtooth wave or a sine wave. And yes, the MTSC, or the MTS signal, the stereo signal in the old days, could be a sine wave, or it could be just a copy of the flyback frequency, or a derived color burst square wave, or a dozen other things. All I had to do is hit the right note, say it's stereo, tell it to turn on the stereo interpretation for the broadcast signal, and yes, a VCR could accidentally trigger that in a TV set where it would try to derive it from some other way. Even though you're feeding two stereo signals, right and left signal, into a TV set, the TV set, if it's a cheap one, might turn on the stereo interpreter and screw with it. I have personal experience with that because I literally did have a recorder and a VCR that was cheap yet high-end at the same time for audio quality. It recorded the MTS signal in band, and it messed with the stereo interpreter. I had to physically, manually select it. It was a cheap VCR. This was the last years you could get a VCR. It was a really good one. It was a high-end one, but the smarts in it were disabled, and it was kind of a stupid VCR, a dumb player. It was one of those all-in-one units. And yeah, it had a TV set built into it, which caused all sorts of trouble. It would inject the 15 kHz into it and say everything was stereo if you're watching TV. And yes, I made it to where it would work as a TV set. That's how I learned about this. So again, when evaluating audio signals for anything that you feel really technically minded about, find out if it's variable bit rate or constant bit rate and what the sample rate is and whether or not it could sample at that frequency, or at least 48, 50 kHz, something like that. This is the reason all of the recordings I ever made have always been 128 kHz sample rate, VBR, or CBR. CBR if I wanted to make sure it was perfectly clean and didn't have aberrations, if it had a lot of hi-hats and audio, people hitting cymbals, or I would have it as VBR because I didn't give a damn and I needed to convert it to something pretty universal. And yes, I used lame for all of this. Now, anyway, if anybody wants to discuss the subject rationally, comment below. If you want to scream, you were always wrong, we were always right, when it was very obviously somebody getting a VCR, putting a porn movie in, and recording the audio as a sample. Because that's what Carl92 did, apparently, or whatever his name is. And yeah, that's how it got there. And he probably had a pseudo bootleg TV set from America, and it was probably one of those all-in-one units like I had. That was the most common, and that's how we got the 15 kHz. And yeah, it was probably a sawtooth wave, and it was probably the flyback frequency, and literally I am vindicated because everybody was just fucking wrong. Neener, neener. Anyway, for anybody else who's curious on the technical level, this is why we use triple oversampling, and this is why variable bitrate isn't all bad, because as soon as it would detect that signal up there, the 15 kHz flyback or whatever, it would immediately switch over to 48 kHz sample rate at least, and we would have oversampling data over a long term and be able to determine its wave shape probably, but it would not be admissible in court as far as quality level. We still wouldn't really know. Thank you for watching. Have a good day. Good luck with all that. And goodbye.